we have one of my sort of favorite topics today um, by Dr. Neeraj Kashyap, who is an Open AI fellow, as well as CEO of Semiotics, where the team is building a search engine for programming errors. Neeraj has in the past worked at Google on TensorFlow and Cloud AI, as well as built AI teams at multiple healthcare startups, where he has pioneered the practice of privacy aware machine learning. Neeraj also has a PhD in mathematics. As I said, I'm quite excited about this topic and keen to learn. Let's get started with how to leverage sensitive data, privacy aware machine learning. For all the attendees, if you have any questions, please submit them on the right side on the session chat. And then I will be moderating those questions in about 20 to 25 minutes.
I'm going to talk about privacy-aware machine learning. I've been working in healthcare for many years. I've worked around data science teams in hedge funds as well, and I've worked, at Google on TensorFlow. But Google takes privacy very seriously. So this talk is sort of a synthesis of my experience, in healthcare, in finance, and in tech. Just some lessons that might be useful to other people who have to do data science in organizations where privacy is sort of the most important thing. Where the access to data is limited because privacy is so important. So that's what this talk is about. And before we continue, I want to actually talk about different types of notions of privacy when it comes to data. So there are the organizations. So just to use Google as an example, Google is an organization that owns a lot of data. That's debatable, but I mean, Google is a custodian of a lot of data, but the data actually represents the users of Google, right? So the data represents people who use Google. Let's think about like search query data or something, but Google is the custodian of that data. And when it comes to privacy, when you're talking about data and machine learning, it's really important to distinguish between the privacy of the custodian versus the privacy of the population actually represented by the data. So, for example, if I built an entire corpus of search queries, the privacy of the custodian, if I were protecting the privacy of the custodian, you shouldn't be able to tell from like a single search query whether that search query came from Google or from DuckDuckGo or from Bing. But if I wanted to maintain the privacy of the user, you shouldn't be able to tell whether person A actually entered the search query into a search engine or person B entered the search query into a search engine. It's important to make that distinction just because different technologies or different techniques to guarantee privacy in machine learning focus on different players. And that's why it's important to keep this distinction in mind as we proceed. So the privacy of the client, which is the privacy of the data custodian, the person who owns the data or the organization that owns the data. And then there's the privacy of individuals, like privacy of the population that the data represents. Okay? Those are the two sort of ideas that you have to keep in mind as we're evaluating privacy techniques in machine learning. And there's a lot of work being done on privacy in machine learning these days. So the research community is very active. A couple of years ago, actually just a little bit more than a year ago, a team at Google published a paper where they talked about how they train a model to predict, if anyone uses the Google keyboard, you can swipe, to write stuff using the Google keyboard. And there's a model that's trained using federated learning on Pixel phones, on the Pixel family of phones. And the team that's responsible for training that model sort of published about it. They're using federated learning to actually train that model. So basically the model gets trained on your device if you're using a Pixel phone, and then whatever, it's a neural network model, and then whatever gradient calculations are done on your phone, they get shipped to Google servers to get aggregated with gradients calculated on other people's phones, and that's how they build a common model for the Google keyboard, roughly speaking. And that set off like this huge explosion of research on federated learning and differential privacy. But that's not what I'm going to be talking about today. So just to make it clear, the reason I'm not going to be talking about it is because a lot of the scenarios. So, for example, the Google Keyboard scenario, you have multiple clients. Those are the actual phones, client devices, and it's important for them to maintain the privacy of those client devices. There might be multiple users represented on a client device and so on, but this is the way that it works. The use case that I'm actually going to focus on today is the use case where you have a single client, like a large organization is an example, that contains data for a large number of people. So this is where my experience really lies. So health insurance companies, for example, they want to train models on claims data for in the US, like hundreds of millions of individuals. A credit card company might want to train, for example, a fraud detection model on the credit card transactions of everyone who has a credit card with them. These are the examples that I'm interested in, and for these examples, and I'll talk about why. These sort of more cutting edge techniques of federated learning and differential privacy aren't yet viable, mostly because they're too new and therefore they shouldn't be trusted. But we'll talk about that in a second. So it's really important, if you end up working at a healthcare company, or if you end up working at, some sort of a financial institution, or if you just have to, build models in that kind of an environment, to understand the context in which decisions are made, right? So in these industries, in industries where you're dealing with sensitive data, there's usually a very high downside to actually leaking that data. So for example, in healthcare, in the US, if you leak a record, like a single medical record, or it could even be a single row in a database, for someone who's trusted you with their data that's covered under HIPAA, you're liable to pay up to $50,000 per record, right? So if you have like 100 million, let's say you have a single record for 100 million people each, you're paying $5 billion. That's your liability on paper. It probably wouldn't end up being that much, but that's the maximum amount that you could be held responsible for. So there's a really high downside to not taking care of data properly, and so the incentives for people who are making decisions in those organizations is to actually protect that downside, and that basically leads to sort of two trends, or basically there are these two principles that affect all their decision making, which is that they need to limit the access that people in that organization have to data, because the more people that have access to data, the more likely you are to have a leak at any given point in time. So the first pressure is to limit access to data, and the second pressure is to not trust techniques that they don't understand, which is very reasonable actually, right? So if you don't know what someone is doing, and you do know exactly what your risk is for them messing it up, you should just err on the side of caution and not let them do whatever thing it is they want to do. So these are sort of the pressures that are applicable, when you're sort of working in this environment, and these are completely counterproductive if you want to do machine learning in such an organization. So basically what I'm hoping to do is, having worked in these industries for some time, I want to at least share some tips to make it easier to get to sort of be productive despite these challenges, right? The people not wanting to give data scientists access to data, and people just being generally suspicious of machine learning because it's something that's fundamentally difficult to understand, right? So as a data scientist working with an organization that does have sensitive data, it's important, first of all, so generally the way that a data scientist works is, this is definitely the way that I worked. I was used to working, comfortable working when I started out. You have some data set, you either get all of it, make all of it accessible to you on like your laptop or your workstation, or you spin up a cluster somewhere that you have direct access to, make the data available to that cluster, do your data exploration, build your data processing pipelines, start training your machine learning models, train your machine learning model in that environment, and then ship it off somewhere for like, production use or, whatever. In these environments, it's good if you can get comfortable working without having direct access to the data. This takes a certain level of support from infrastructure, at the level of infrastructure and engineering, but being able to, of putting tooling in place, but being able to comfortably work with data that you don't have direct access to is very important. And then the second thing is it's important to realize that your objective function shouldn't just be your utility function for whatever model you're training, but there's also this sort of meta game where transparency and explainability are important to your organization. So if something does go wrong, it's really important to be able to understand why it went wrong. That's that's also a priority, not just the performance of your machine learning model over your evaluation data set or something like that. So these are important things to sort of absorb, internalize, and let's talk in a little bit more detail about what it takes technologically to make these things happen. So the first thing is creating a protocol. So it might seem like a lot of red tape, but it's quite useful when you're working with an organization where access to data is like a very serious thing. To actually create a protocol before you start your work about what you're trying to achieve, what data you're going to use to achieve it, how that data is going to be handled, and this is really important, and what information you're going to need to extract from that environment in order for you to be productive. So that's the metadata that data scientists consume between experiments. And then basically where the results of your work are, how those will be handled. So those are the model artifacts. When I say a protocol, so this is sort of motivated. I had the interesting experience of being principal investigator for a clinical trial a couple of years ago, and that's where I sort of like started developing these ideas. But more than the protocol for a clinical trial, it's really important that each of the components of the protocol that you create here come with code. So you don't want to sort of be manually pushing Jira tickets around or running commands in your terminal to like move data from your production replica to S3 or that kind of thing. Everything should be sort of scripted, so it can trigger automatically when like the next step of the protocol should be applied. The reason that should be done is because you shouldn't assume that you're going to be running the code, right? Because ultimately there's going to be some sort of security team or some sort of an infrastructure team or some sort of an engineering team that should be running that code. It shouldn't be you as a data scientist. And having things scripted in this way makes it easier for them to do so. So, for example, you can put each of the things in the protocol into like some sort of a continuous integration pipeline, so that when you push like a new model update to GitHub or to GitLab or whatever you're using, data can automatically be synced from your production environment. Whatever series of models that you want to train can be trained, and you can receive your evaluation metrics by email or by Slack or whatever your favorite channel is, without a human being having to like actually go and trigger any of those steps. And if required, there can be some sort of a manual like security review to make sure that no unnecessary information is leaking as part of any of the artifacts of that pipeline. But there shouldn't, you should never have to step in. So when I say protocol here, I mean like something that comes with code. So that's like a very useful first thing to do. The next thing to do is to make sure that you have sort of isolated infrastructure for your experiments that doesn't necessarily interact, that interacts with your production environment in only a very controlled way, and that you as a data scientist don't have the more access to than you need, right? According to like, whatever teams you're working with and so on. So for example, you might be working with you might be working with an organization or in an organization that doesn't want you to have direct access to even like, whatever data is used for training. So they don't want to, let's say that you're running like VMs in the cloud or something, they might not want you to have direct SSH access to those VMs, but you still have to be able to trigger some sort of, computation on those VMs in order to be effective. So the core functionality that you need is actually just, you need to be able to request that data be synced into your, whatever data science environment you're using from production. You need to be able to trigger aggregation. So basically, this is a stand-in for exploration, right? You should be able to like calculate histograms, for particular features in the data. You should be able to calculate, like different statistical moments for like features in the data, numerical features in the data. You need to be able to do counts for categorical features in the data, things like that. You should be able to trigger those aggregations. You should be able to trigger training of machine learning models, and you should be able to trigger evaluation of models that you've trained, right, against some evaluation data sets. And you should be able to request that some metadata be exported from this environment to you. So you should be able to get those histograms that you calculated, or you should be able to get the evaluation metrics from your training or evaluation jobs. So that's like the sort of bare minimum of things that you need to be able to do. Chances are your, whatever organization you're working with will not mind if you have more access. They won't mind giving you SSH access, but it's just important to understand that like this is the core functionality required for you as a data scientist in an isolated data science environment. And then you need to have some way of communicating with your environment. So, these are all the things that you need to be able to do, but how are you going to do them? And so there are a few frameworks that you can use that actually give you this level of access to an isolated environment. So for example, MLflow is actually quite popular, and they have an API with authentication mechanisms and things like that you can use to actually trigger the kind of jobs that you need to trigger. And at Semiotics, we've been working on a framework called Schnorky that allows you to do the same thing. So these are all perfectly good options that allow you to basically dictate what kind of computation occurs on data in a remote environment, even if you don't have direct access to data, and like meaningfully train machine learning models even under those constraints. So that's as far as like, principles of like, being able to work with data in an isolated environment. The other thing that we mentioned, where we have to like expand our comfort zones is around transparency, about realizing that we also have to prioritize things like, interpretability and sort of inspectability of whatever work we produce in our data science environments. So generally, when people talk about interpreting machine learning models, they talk about interpreting machine learning models in terms of the parameters of that model. So, let's say that you have some sort of a linear model. It's generally not too difficult to basically like, eyeball your coefficients and understand like how that model is doing what it's doing. With things like neural network models, using the model parameters to understand the behavior of the model is a lot harder. So it's also important to sort of build good reference data sets that you can use to contextualize your models, because in the absence of being able to just understand exactly how the parameters affect, whatever predictions your models are making, being able to contextualize those predictions in terms of these reference data sets using, benchmarks is a pretty good stand-in. So that's it's important to build these good reference data sets. And if you have to do that in your data science environment, you also need to like, set up the right tooling and add that in your protocol, things like that. The other thing, and this is something that people don't often consider, and maybe people don't often consider it because they're already using text formats, or if they're not, then they're like really biased against them. But it's most of the things that you do in like let's say a health insurance company are going to have to pass through security review, and it's a lot easier for things to be reviewed if they're available as text, in a textual format rather than as a binary format. Like, so some custom protobuf format probably isn't going to yield to easy security review. So just keeping things in text formats is quite simple. So even if you have to do this with model weights and so on, maybe you can use PMML. Maybe you can, so for example, if you want to build a TensorFlow model and you want to use like a TensorFlow serving binary, you can always sort of store the weights separately and then integrate them into the TensorFlow serving binary before serving time. But if you do that, then the text files are the only ones that get transferred between environments. It's easy to review them. And in general, it's important to have really good access logs, and it's important to have really good access logs, and it's important for you to also consider error messages as a kind of metadata that you're extracting from your data science environment, because there are going to be a lot of errors, and if it's not an environment where you're directly executing code, you're not going to have that same feedback loop with errors that you do in your Jupyter notebook or on your laptop. So it's really important to basically build up a good workflow around reporting errors for you as a data scientist, and for your organization, it's really important to have those access logs available to them so that they can make sure there's nothing suspicious going on in those environments. So that's it from me. Those are just a few things I've learned over the years of doing data science in organizations that don't want you to do data science very freely. I hope that helps. Right?
Thank you, Neeraj. That was that was awesome. I did have one question, and it's in one of the last few slides. You talked about sort of security audits. Do you think that the security audits for machine learning-based products or processes are different? Should they be different? Has the sort of security profession caught up to how we should be sort of doing threat assessment of machine learning models?
I don't think it has, actually. I think, and it's actually a very difficult thing to do, right? So especially when you're talking about training models. So if you're training models, there's all kinds of code that you can hide in your model training, whatever code you ship for model training, that could steal data and hide it in a binary somewhere, and it would be really hard for a security audit to catch a hold of. So I don't think there's actually a good answer right now, just because it's a very hard question. But yeah, I don't think the security space has yet caught up with what. So,
are they applying any new sort of approaches, or is it still more sort of the traditional way of sort of threat modeling? It's much more sort of traditional. Can I inject code, or can I do this, or can I access something I can't access?
Yeah, I think for the most part they're doing things like monitoring network calls and monitoring like CPUs, that basically just seeing if there's anything anomalous with computational profile.
Right.
I think the differential privacy people might actually have useful things to say over here, but I just don't think that's seeped into traditional security teams.
We have a few more questions from the audience, from Abdul. Any best practices around de-identifying sensitive data?
My best practices, and this is what I always use, is just like a series of filters. I just have some little pipelining framework that applies a series of filters to data iteratively until I have something that's ready to go. And I think so. Actually, right now, if you go on, I think Google also made public their de-identification framework, which works pretty much the same way. They have a much better set of rules. They have off-the-shelf rules that you can use and drop in for de-identification. Yeah, I've seen people try fancier things, but none of them have worked. It's usually just keep it simple.
Right. Next question is from Khalid. Can you talk a bit more about the applicability or not of differential privacy from your experience to solve data access problems?
I worked at a healthcare startup where we actually deployed a federated learning network, and we were looking at sort of these differential privacy calculations in order to guarantee the privacy for our users. But as far as I can tell right now, it's not very applicable. It's it's actually very difficult to even quantify, so with differential privacy, you have like all these different parameters, right? Like, you can be epsilon differentially private, but if you want to quantify the level to which you're differentially private, like if you want to quantify that epsilon, you need to have a large data set that you can use to actually make an estimate of epsilon in the first place. And most people are actually resorting to these solutions where you need to differential privacy because they don't have access to those data sets. So it's not I don't think it's applicable, but even quantifying how inapplicable it is would require like us to do more work.
Right. It's stats on top of more stats, right? It never really ends.
Exactly.
Next question is from Nigel. How privacy is being considered in data engineering before it even sort of reaches data scientists, right? Like what could you be doing there, or what should we be thinking about?
Actually, most of the stuff I mentioned were really engineering concerns rather than data science concerns. So actually, everything I mentioned about the isolated environments, being upfront about what the identification needs to be performed on the data before it reaches those isolated environments, those are all data engineering concerns. For the most part, I think actually keeping track of like how features have been transformed from the original data before they're actually made available to the data scientist, that's something where there's an overlap, but besides that, it's mostly a data engineering concern.
Question is from Yanni. Literature that you would recommend for people to read around these topics?
Yeah, actually, if you're interested in what's going on in machine learning research, there's on the slides, I think we'll share the slides after this. There's a link to a paper called, let me find it. It's called Advances in Open Problems in Federated Learning. Yeah, Advances in Open Problems in Federated Learning. That's a survey paper that actually will bring you up to speed on all the research that's been done over there and like what direction people in the research community are looking to move in as well. So that's a really great paper to start with.
That sounds like a great suggestion. Yeah, someone did ask about whether you'll be sharing the slides, so that's great. The next question: are there any other tools you would recommend for data treatments, differential privacy, audit monitoring? What has sort of the end-to-end package for you to care about everything sort of other than the analysis?
I don't know any of the tools Derek mentioned in that in his question. Generally, I've generally just like written my own. My teams have written our own code in order to. I can't hear you, Monish. I think you're muted.
Sorry, I was on mute. Somebody just So Neeraj just answered. Yeah, that is the. Thank you so much, Neeraj. This was great, and the number of questions tell you that you really sort of got people's attention and interest. So thank you so much. If we were all in a room, we would be sort of clapping. So thank you.
All right. Have a nice day, everyone. Bye.
Yeah. Everyone, you can sort of join the networking area and the expo area. So we'll see you there.